All right, we're back. We are on page 9 of notes. Nope, we're on page 2 of notes 9. I was going to say 9 of notes 2, but that's not true. We're talking about derivatives of inverses, and we already we have a little bit of a speculation that perhaps the derivative of the inverse is the reciprocal of the derivative of the function. And now what we're going to do is we're going to look at a little more complicated example. So that used lines, linear functions, just like everything simpler about them, right? The slope is constant, so you don't have to think quite so much. Let's take a look at this one though. So there's a lot of stuff on this grid for sure. So we have a function f of x and the tangent line to the function. So I'm going to do a little highlighting there and say that, so this must be our function. Why? Man, my hands are so unsteady. There. Okay, so this is our function. So that's f of x. And then we have a tangent line to the function. So the tangent line, oh, because this will snap to a line, so that'll look good. Okay, so we have a tangent line to the function. So we have a function, we have a tangent line to the function. What is the point of tangency? So the point of tangency, you can see, is definitely -2, 0. Wait, is it not just given? What is the corresponding? Okay. So point of tangency. Point of tangency is -2, 0. Okay, so the corresponding point on the inverse is going to switch x and y. So it's going to be 0, -2. So the corresponding point that we're looking for is here, 0, -2. Okay, use any 2 points on the tangent line shown. Find the derivative of the function at the point of tangency. So the reason that that's going to work is, the tangent line and the curve have the same slope at the point of tangency. So I can actually use the tangent line to find the slope. And I'm just going to count it off. So you go up 6 and over 1. So 6. So let's say f prime of -2 is 6 because we went up 6 and we went over 1. For the 2 additional points on the tangent line, add the corresponding points on the graph of the inverse function. So 2 additional points on the tangent line, corresponding points on the graph of the inverse. Those points aren't on the graph of the inverse. They should be on the tangent to the inverse. Okay, so, or maybe I meant the inverse of the tangent line. That could be. Actually, if I meant that, that was good because maybe that provides more clarity. Anyway, this is -1, 6, so it'll be at 6, -1. And then this point here is -3, -6, so it'll be at -3, it'll be at -6, -3. Switching points is like my nightmare. All right, so let's see. Tangent, I'm drawing the tangent line. Going through. And then, all right, I think I can fix this a little. Nope, I cannot. Why not? Oh, wait, there we go. Dang it. I had it for a second and then I lost it. There we go. Okay, so I'm sorry you have to watch that. So we did it, I think. Sketch the tangent line. Use the points on the tangent to the inverse to find the derivative of the inverse at the point of tangency. Okay, so if this is g of x, which is equal to f inverse of x. Wow. F inverse of x. It's like there's doing a bad job and then there's doing a really bad job. All right, so what's the slope of this thing? We go over 6 and up 1, so 1/6. So that's going to be g prime. So g prime of 0, because the point of tangency here is 0, -2. So g prime of 0 is we went up 1 and over 6. So what is the random point? Oh, there's a random point. Look at that. Okay, so let's just take a second and think about what we just did. So we said that on the original function, we have the point -2, 0, which means on the inverse function, we have the point 0, -2, right? You switch x and y. The slope at -2 on the original function was 6, but that's the slope at -2 on the original function, right? Slope at -2 on the original function is 6. The corresponding point is 0, -2. So the slope at 0 on the inverse is the reciprocal. So here we got, let's highlight. We got 6 here, 1/6 here, and the point switched too. This was at -2. This is at 0. So the point switches because x and y switch. And if x, one way of thinking about it, and it's actually kind of how I think about it, is like on the original function, it's like delta y over delta x. When you switch x and y, that becomes delta x over delta y. That's why you're just switching, you're just flipping that slope over, I guess. That's how I think about it. All right, now there's a random point. What is the value of the derivative f of x at the random point? Random point right here is at 0, 4, and f prime of 0 is definitely 0 because that's horizontal. So f prime, so the point on f of x is 0, 4, and f prime of 0 was 0, horizontal tangent line. The corresponding point will be 4, 0, right? Because you switch x and y. This point is 0, 4. So 4, 0 is the corresponding point on the inverse. So here, I guess I could put these lines in, especially because they're lines and it'll do the work for me. So there's your tangent line, but let me move it. Okay, there's our tangent line. And then at 4, 0, we're definitely getting a vertical line. I'll do it in this weird green color, or I'll try. That's not even a whatever. Okay. I wish you could see the things that I mess up. It's like a weird wish, but that's what I wish because it just seems so weird when I'm like, no, that slope is definitely undefined. So the point on g of x, which is equal to f inverse, so the point on the inverse is going to be 4, 0 because we switch x and y, and then g prime of 4 does not exist because it's kind of like 1 over 0, right? You're trying to take the reciprocal of 0 and you can't do that. So that's like the basic idea. That's actually the idea. It's not just the basics of the idea. So let's just go through this and then we'll call it a video. So if we know, so I do this all the time. If we know that AB, so this is going to be annoying, AB is on the graph of f of x, then BA is on the graph of f inverse. That's really important. You switch them, right? And then if we know the slope at x equals a, what are we doing here? Here's a. So the slope of g of x, which is f inverse, so g prime of a, no, sorry, g prime, okay, confusing this more than I need to. It's because I'm trying to color things in. Let me just finish coloring, everybody. Sometimes you got to take time for yourself. B, everywhere I see B, I'm going to color it. You know, you feel free to highlight with me, do whatever you want. Okay, okay, whew. All right, here we go. I got this, maybe. Why don't I just read it? If we know that the point AB is on the graph of f of x, then we know BA is on the graph of f inverse, which we're calling g of x for simplicity's sake. We also have seen, or saw, that since creating the inverse involves swapping x and y, the slope of f inverse at BA, f inverse is what we're calling g of x. So the slope of f inverse at BA is the reciprocal of the slope of f of x at AB. So basically the whole thing comes down to this, that g prime of b, where b is the y value from f of x, g prime of b is equal to 1 over f prime of a. That's how I do it all the time. I'm going to stop the video here. I will be back in the next one to keep going, and I will see you there.